Unit 5, Similarity, Lesson 1, Ratios, Proportions, and Similar Polygons. Your objectives for this lesson are to write and use ratios, as well as to use properties of proportions and identify and use similar polygons. First up, a ratio is a comparison of two quantities by divisions. The ratio a to b, where b is not 0, can be written as the fraction a over b or as a to b, this comparison here. So you've seen ratios before because every fraction is a ratio. Example 1. In 2007, the Boston Red Sox baseball team won 96 out of 162 games played. Write a ratio for the number of games won to the number of games played. So your instructions here say write the ratio for the number of games won. 2 in a fraction is this line, so that line means 2. The total number of games played. Okay, so number of games won, they won 96. I'm just going to plug that in over they played 162. So this is what we're going to start off with, but I actually want to simplify this fraction. So I know that 96 and 162 are both even numbers, so they are both divisible by 2. So 96 is really 2 times 48. 162 is really 2 times 81. And now these 2's cancel. Taking this a step further, I know that both of these numbers are divisible by 3. 48 is 3 times 16, and 81 is 3 times 27. So these 3's cancel. And 16 and 27 cannot reduce anymore. So my ratio is 16 out of 27. Example 2. The ratio of the measures of the angles in triangle JHK is 2 to 3 to 4. Find the measures of the angles. The first thing I'm going to do is draw a picture. I already have one started here. And I'm going to name the angles 2x, 3x, and 4x. And I know that these numbers go in the same order as the letters, so I have J, H, K. All right. And I know that there are 180 degrees in a triangle. So 180 is equal to my 2x plus 3x plus 4x. If I combine my like terms, I get 9x. And I can solve for x by dividing by 9. So x is 20. But I don't want to find x. I want to find what each angle equals. So right here I'm going to plug in my x. 2 times 20 is 40. 3 times 20 is 60, and 4 times 20 is 80. So my 3 angles, I can say the measure of angle J is 40 degrees. The measure of angle H is 60 degrees. And the measure of angle K is 80 degrees. And that's my answer. A proportion is related to a ratio because it is a statement that two ratios are equal. In the proportion A divided by B equals C divided by D, where B and D are not 0, the values of A and D are the extremes, and the values of B and C are the means. The cross product property you've used before, even if you don't know what it's called. says that in a proportion, the product of the means is equal to the product of the extremes. So A times D equals B times C. Looking at this, A, D, B, C, that's just cross multiplication. So the cross product property, remember product means multiplication. This is talking about cross multiplication. Okay, example 3, solve the proportion 9 over 16 equals 27 over x. We're going to do this by cross multiplying. I'll show you 2 different ways. So first, I'm just going to say 9x equals 16 times 27. Okay, so 16 times 27 is 432. So we have 9x equals 432. We can divide by 9, and we get x equals, do you think it will be, divide by 9, 48. X is 48. Okay, so we found x. That's good. If you don't like that way, you may have seen this other way before also. I can just say x equals 16 times 27 divided by 9. And if you have a calculator, you can put this in one straight shot, so long as you put the top part in parentheses. And if you do that, you will still get x equals 48. Either way is fine. Example 4. Mayor Hernandez conducted a random survey of 200 voters and found that 135 approve of the job she is doing. If there are 48,000 voters in the town, predict the total number of voters who approve of the job she is doing. Okay, so we have to set up a proportion. Now remember, when you set up a proportion, you're going to say part divided by whole equals part divided by whole for this type of problem. Okay, and the first thing I'm going to look at is the survey. So the survey part and whole are going to go together. So I had 200 voters total, so that's going to go for the whole. And 135 approve of her job that she's doing. So we're going to put that in for the part. So we have 135 out of 200 equals. There are 48,000 voters in this town. That's the whole. That is the total number of voters in the town. And we are looking for the part who approve of her work. I'm going to put an X there. Now we're going to solve by cross multiplication. So we have 135 times 48,000 divided by 200 equals X. I'm going to put parentheses around this top part before I whip out this calculator. Okay. So 135 times 48,000 is a big number, so 648,0000. Divide that by 200 and we get 32,400. So X is 32,400. Okay. So basically, we're predicting that 32,400 voters approve of her work. That's my answer. Similar polygons. So we're changing gears slightly, but not entirely. You'll see in a second. Similar polygons have the same shape, but not necessarily the same size. This is how they're different from congruent polygons, so congruent polygons would have the same size. Similar polygons may or may not. In similar polygons, the corresponding angles are congruent and the corresponding sides are proportional. So angles are congruent, sides are proportional. Example 5. If triangle ABC is similar to triangle XYZ, list all pairs of congruent angles and write a proportion that relates to the corresponding sides. So this symbol here means similar. And just like before when we were looking at congruent triangles, we're going to write our similarity, we're going to write the congruent angles for similar triangles in the same way. So let's look at our angles. I'm going to start in the front. Angle A is going to be congruent to angle X. They both appear first in that similarity statement. So angle A is congruent to angle X. Who comes second? B is second. Y is second. So angle B is congruent to angle Y. Last, we have C and Z. So angle C is congruent to angle Z. Now we need to write a proportion that relates corresponding sides. Okay, well, I'm going to start with my first triangle here. I have side AB on this triangle. AB. And I know that AB in position 1 and 2 corresponds to XY in position 1 and 2. So XY. This says side AB is proportional to side XY. Okay. Equals. Next side, BC over YZ. So we had 2, 3, 2, 3. Okay, but I know I'm going to have 3 sides. So next I'm going to say AC over, so 1, 3, 1, 3, XZ. Okay, this is my proportion relating corresponding sides. And you'll notice I've used each letter exactly twice. So A, 1, 2, B, 1, 2, C, 1, 2, X, 1, 2, Y, 1, 2, Z, 1, 2. And that everywhere I have an A, I have an X. They're lined up. Everywhere I have a B, I have a Y. C, Z, all lined up. That is what you want to have. Example 6. Determine whether the pair of figures is similar. If so, write the similarity statement and scale factor. Explain your reasoning. Okay, so the first thing I want to check here are angles. I should have, since I have 4 angles per figure, I should have 4 pairs of congruent angles. And I'm going to use different colors to mark which angles go together. So I see W has 1 arc. So over here, P has 1 arc. Next, Z has 2 arcs. S has 2 arcs. So that the arcs, remember, mean that those angles are congruent. And the ones with the same number of arcs are the ones that are congruent. Y has 1, 2, 3 arcs, meaning it's congruent to R with its 3 arcs. And X and Q both have 4 arcs. Now that I've circled these, I can see that WX should correspond to PQ, XY should correspond to QR, YZ should correspond to RS, and ZW should go with SP. Let's see if this works. So if I take WX, divide it by PQ, I get 12 over 8, which simplifies to 3 halves. Okay. And this would be my scale factor for moving from WX to PQ. If these two figures are similar, then each pair of corresponding sides will have the same scale factor. So let's take a look at that. I'm going to say XY over QR is 18 over 12. I'm going to write these all out, then I'll simplify them all at once. So YZ over RS is 15 over 10. And then WZ over PS, 9 over 6. So simplifying, these are both divisible by 6. 18 over 6 is 3. 12 over 6 is 2. Okay, so far so good. These are both divisible by 5, and I get 3 halves. Both divisible by 3 halves. And you see that these are all the same. So yes, those are all, yes, these are similar. And I'm going to say WXYZ is similar to PQRS. So this is my similarity statement. And my scale factor is 3 halves. And we've already said, it says explain your reasoning, that we have 4 pairs of congruent angles, and the corresponding sides all have a scale factor of 3 halves. Example 7. The 2 polygons are similar. Find X and Y. So these are similar, which means I can go ahead and match up my angles again. So S is congruent to N. We see the one arc. T is congruent to P. They both have the 2 arcs. And R is congruent to M with their 3 arcs. That means, so I'm going green to red, that 13 and 16 are similar. So if I look at RS over MN, I get 32 over 16, which gives me a scale factor of 2 over 1, technically. Okay. So now if I'm looking at ST and NP, I have 2 over 1, using my scale factor, equals ST, which is X, over 13. And if you wanted to do this without simplifying this first, you can. You could say 32 over 16 equals X over 13 and solve it that way. This way just gives you a little bit more simplified multiplication. So we're going to end up with 2 times 13 equals 1 times X. 2 times 13 is 26. 1 times X is just X. So I can cross out my X and put a 26 there. Now again, we're going to find Y. So 2 over 1 equals 38 over y. Cross multiplying, and I get 2y equals 1 times 38. So 2y is 38. Divide by 2, and we get y is 19. Okay, another way that you could have done this, if you notice that these numbers over here, like 32 is 2 times 16, you could have just taken that 13, multiplied it by 2, and gotten 26. Similarly, you could have just divided that 38 by 2 to get your 19. And that's just a little bit of a shortcut if you notice that. If you don't notice it, don't worry about it. The cross multiplication will work. Example 8, this is our last example. If triangle DEF is similar to triangle GHJ, find the scale factor of triangle DEF to triangle GHJ in the perimeter of each triangle. Okay, well, let's look at my corresponding sides, or angles. D and G go together. E and H go together. And F and J go together. So on triangle GHJ, I really only have one side, and that is 12. So HJ, blue-green, goes with blue-green, so that's 8. To find my scale factor, I'm going to use EF and HJ then, because HJ is the only side I have on this triangle. Get 8 over 12, which reduces to 2 over 3. So this is my scale factor. Let me write that here. Scale factor is 2/3. Okay. And the perimeter. Well, to find the perimeter of this small triangle is really quite simple. All I have to do for triangle EFD, or DEF, how do we call it? DEF. Triangle DEF is add up our 3 sides. So perimeter is just the length around the outside. We're going to say 8 plus 12 plus 10, which is 30. Okay, now there are 2 ways to find the perimeter of triangle GHJ. So perimeter of triangle DEF is 30. The first way is to find each side and then add them up. So let's try that. I know that ED goes with HG. So I'm going to call this side X, this side Y. And 2 over 3, my scale factor, equals 10 over X. So this is for HG. So 10 and X go together, and our scale factor is 2/3. So cross multiply, we get 2X equals 3 times 10. So 2X equals 30. Divide by 2. And our side length is 15. Okay. Now to find GJ. Again, 2/3 equals, going to say 12 over Y. Cross multiply, 2Y equals 3 times 12. So 2Y is 36. Divide by 2, and Y is 18. Okay. So now that we have these side lengths, I can add up as I did before. So we have triangle GHJ is, what was our first side? 12 plus 15 plus 18, which gives us 45. Okay, so the perimeter of triangle GHJ is 45. But I told you that there are two ways to find the perimeter, so let's look at that second way. And it really is a little bit faster if you don't actually need to know what those sides are. Once I've found the perimeter of my first triangle, I know that that is 30, and I have a scale factor for the side lengths of 2/3. So what I can do is use that information and say 2/3 equals 30 over the perimeter of the second one. I'm going to call it P. Cross multiply, so 2P equals 3 times 30 is 90. Let's make that look like a 0, not a 6. So 2P equals 90. Divide by 2, and my second perimeter is 45. So I got the same answer that I did before, but that took me 3 lines of work as opposed to, I don't know, like 10 lines of work there. So that's a lot faster. And here's my answer. And that is the end of lesson 1.